In this video, we're going to look at how we can balance equations. So equations have to be balanced so that we end up with the same number of atoms on each side of the equation, the products and the reactant side. And we're going to balance it by using coefficients, which are the big numbers in front of the compound or the element that is there. The first equation we're going to look at to balance is this one right here. Aluminum oxide produces aluminum metal and oxygen gas. And so when we look at this, we have to decide where are we going to start. Well, you have aluminum on the product side that does not have a subscript, and so that is the easiest to balance because we can put any number as a coefficient in front and that will balance the aluminum. So for this particular equation, we're going to start with oxygen. We have a subscript of 3 in front of the oxygen in the aluminum oxide compound, and we have a subscript of 2 for our oxide or oxygen on the product side. So since we have an odd number on one side and an even number on the other, we're going to come up with our lowest common multiple of that, and so that would be 6. We need to get 6 oxygen on each side. We can do that by putting a coefficient of 2 in front of the aluminum oxide. That gives us 6 oxygen there. You multiply the coefficient by the subscript to give you how many of that particular element is present. So that's 6 oxygen on the reactant side. We put a 3 as a coefficient in front of the oxygen on the product side. The 3 times 2 over on for the oxygen is 6 as well. So look back at aluminum. If we look at aluminum oxide, we have a 2 in front. Aluminum has a subscript of 2, so 2 times 2 gives us 4 aluminum atoms. So we can put a a coefficient of 4 in front of the aluminum, and that balances that equation. Let's look at another example. In this one, we have C2H2 reacting with oxygen to produce carbon dioxide and water. So we have, one thing you should notice is that you have oxygen in 2 different compounds on your product side. It's in carbon dioxide and water. And so that is an element that you are going to want to balance last. We want to balance everything else first and then see how we can balance the oxygens. We'll start with carbon. So on the reactant side, we have 2 carbons. So I can put a coefficient of 2 in front of carbon dioxide. That gives us 2 carbons. If we look at water, has 2 hydrogens, and from our reactant C2H2, we have 2 hydrogens. So hydrogens are balanced as is. So now let's count up all of the oxygen that we have on the product side to see how we can balance that. In carbon dioxide, you have a subscript of 2 for the oxygen. So we're going to multiply that by our coefficient. So that means that we have 4 oxygen. And for the water molecule, we have 1 oxygen. So that gives us a total right now of 5 oxygens on the product side. If we look at oxygen on the reactant side, it's O2. So they come in 2s. We need an even number, and right now we have an odd number on the product side. When you encounter this, the solution to this is to double all of the coefficients that you have placed so far. So we balance this equation with an understood 1 for the C2H2 compound. So we're going to put that as a 2. We have not decided what oxygen's coefficient is. We will leave that blank for now. But we are going to put a 4 in front of the carbon dioxide and a 2 in front of the water. Now the carbons and hydrogens are still balanced. We just doubled all of them. We have 4 carbons on both sides. We now have 4 hydrogens on both sides. So now let's look back at our oxygen. For carbon dioxide, we now have 8 oxygen. For water, we now have 2. That gives us a total of 10 oxygen on the product side. And so we can put a coefficient of 5 in front of oxygen on the reactant side, and that will balance the oxygens. Here is one last equation to balance. We have sodium phosphate reacting with magnesium chloride to produce magnesium phosphate and sodium chloride. Before we get started on balancing, I want you to notice one thing, and that is in this equation here, we have a phosphate polyatomic ion. I'm going to circle it in red so you can see it. When we balance our equation, if you have a polyatomic ion that is intact on both sides of the equation, so it didn't decompose, it didn't turn into anything else, you still have phosphate in this case on both sides, we can treat that as a unit and balance how many phosphates do we have on the product side versus on the reactant side, instead of looking at balancing oxygen separate from the phosphorus. Just simplifies it. And so since we're talking about the phosphate, that might be a good place to start for balancing. On the reactant side, we have one phosphate, one PO4 unit. On the product side, we have a subscript of 2 outside of parentheses around the phosphate for magnesium phosphate. And so that means that we have 2 phosphate units on the product side. So we can put a 2 coefficient in front of sodium phosphate to give us 2 phosphates for the reactant side. So phosphate is balanced. Next, let's look at sodium. We put a 2 in front of the sodium phosphate on the reactant side. Sodium has a subscript of 3. And so 2 times 3 gives us 6. That means we have a total of 6 sodium on the reactant side. We need 6 on the product side. So I can put a 6 in front of the sodium chloride. That gives me 6 sodium. So now sodium is balanced, phosphate's balanced. Let's look at chlorine. So chlorine, you have 6 from sodium chloride on the product side. To get 6 on the reactant side, I would need to put a 3 in front of the magnesium chloride because chloride in this compound has a subscript of 2. So 3 times 2 gives me the 6 I need. That also gives me 3 magnesium on the reactant side, which matches up with the 3 magnesium that I have on the product side from the subscript of 3 in the magnesium phosphate. And so that balances that equation. And that goes through just a few examples of how to balance equations by looking at what's going on in them.